So in this video, we're going to be running through example practice problems with average atomic masses. So as always, feel free to pause and try to work these out, and then you can see how I work them out. So our first problem, take A, isotope A at U equals 10.012, and isotope B at U equals 11.08. You find that the average atomic mass of A and B, assuming they're talking about the same element here, is 10.81 U. The question is, what is the percent of A and what is the percent of B? So to solve this, we're going to need to have two things handy. For one, we know that the percent of A, so let's just call that FA, plus the percent of B, FB, has to add up to 1. And that's because if you had 10% of isotope A, the other 90% has to come from isotope B because we don't have any other isotopes here. And that means that the 0.1 from the A plus the 0.9 for the B has to add up to 1 because you have to add up to 100%. You can't have 110% of an element, and you can't have 90% of an element. This is supposed to represent the entirety of the element that exists. So FA plus FB equals 1. And then you also know that 10.012 times FA plus 11.08 times FB equals 10.81. The weighted average is going to be the mass of A times its percentage plus the mass of B times its percentage. So now at this point, we can substitute something in for this FA. What we can do is up here, we can rewrite this. FB equals 1 minus FA, and FA equals 1 minus FB. These are both true. So we're going to sub this in for FA. Instead of writing FA, we're going to write 1 minus FB. So let's go ahead and do that. 10.012 times 1 minus FA plus 11.08 times, FB times FB equals 10.81. Now let's distribute this, and we'll get 10.012 minus 10.012 FB plus 11.08 FB equals 10.81. And let's combine these two terms. So negative 10.012 plus 11.08. What's that? 11.08 minus 10.012 equals 1.068 FB. So 10.012 plus 1.068 FB equals 10.81. And let's get FB on its own. So we'll do minus 10.012 minus 10.012. And this will leave us with 10.81 minus 10.012. Let me give myself a little bit of space. This equals 0.798. Finally, we can divide both sides by 1.068. Divide by 1.068. And we get FB equals 0.75, just about. So that means that the isotope B is at a frequency of 0.75. 75% of all the isotopes come from B. So how many come from A? Well, this is the much simpler part. Remember, Fa plus Fb equals 1. So Fa plus 0.75 equals 1. That means Fa has to equal 0.25. So we just found B has a frequency of 75%, and A has a frequency of 25%. And if you're ever unsure about your answer, you can simply plug them back in. So let's do 11.08 times 0.75, and that will give us 8.31. And then let's do 10.012 times 0.25, and that'll give us 2.503. If we add these together, we'll get 10.813, which this is because I rounded earlier. So this is basically 10.81. So we did it right. Let's move on to the next example. Say that you have one isotope of copper, which is copper 63. So you have copper 63. And the atomic mass of copper 63 in units, in atomic mass units, is 62.95. And then let's say that this is an abundance of 69.1%. You don't know what the atomic mass in units is of the other copper isotope, other Cu. You don't know what its U is. Find the mass of this other isotope if the average atomic mass is equal to 63.546. So copper 63, whose atomic mass units are 62.95, is an abundance of 69.1%. You want to know how heavy the other isotope of copper is if the average atomic mass is 63.546. So let's see, how would we solve this? Well, this gives you frequency. We'll call this frequency K for frequency of the known. And let's start by finding the frequency U, frequency unknown. So we know Fk plus Fu equals 1, and Fk equals 0.691. So that plus Fu equals 1. What does Fu equal? Well, 1 minus 0.691 is equal to 0.309. So you know that Fu is in an abundance of 30.9%. Well, let's simply plug in. So we'll have the equation Fk times weight K plus Fu times weight U equals 63.546. Fk is 0.691 and weight K is 62.95. Fu, we just figured out, was 0.309, and weight U is what we don't know, so let's call that X, equals 63.546. Now we just have to solve. So let's see. 0.691 times 62.95 is equal to 43.5. So 43.5. That plus 0.309x equals 63.546. And let me give myself a little bit of space here. We'll subtract this 43.5 from both sides, and we'll be left with 0.309x equals 63.5. What does that say? 546? I can't read my handwriting. Minus 43.5. So let's figure out what that is. 63.546. That equals 20.05, just about. So then divide both sides by the 0.309. Sorry about that. Divide that by 0.309, and you'll be left with x equals 20.05 divided by 0.309, which equals 64.9 units. So this tells you that the other isotope's mass is just about 64.9 units. And per usual, we can always just plug that in to see if it makes sense. Let's do 64.9 times 0.309 plus 62.95 times 0.691. And let's see what that gives us. So 64.9 times 0.309 is equal to 20, about 20.05. And then 62.95 times 0.691 is equal to just about 43.5. So we add those two together and we get 63.58, which is just about what we had.